So we are going to learn how to make a function in R. Let's start off by looking at the structure of a function. So to build a function, you need to use the function. And in there, you need to provide arguments, but we'll go into more detail later. So this is the basic skeleton of a function. And what you put inside the brackets here are arguments. So I'll just call my first argument arg1, just as an example. And then essentially what we're trying to do here is in these curly brackets, we have to tell R what exactly we want to do with arg1, right? Because we can specify an argument, but what do you want to do with it? Is it just sitting there? Is it going to be added to something? Is it going to be divided by something? We need to provide that context. So this space between these curly brackets is where we provide that context. And you can always save the function to a variable. I'll call mine add num because I know what the context of this function is going to be. We're going to add two numbers together and then print them to the console. So by doing this, you can run the function just by referencing add num and the argument, but I'll explain what that means later. So this is the skeleton of a function. We have an argument here. I'm going to change this to num1 actually, just num1. And what I want to do is I want to take this argument and I want to add 2 to it. That's all I want to do. So I'm going to create another variable inside of my function called temp num, and I'm going to take my argument num1 and I'm going to add 2. So let's run that. And if I want to use this function somewhere in my code, if I need to add 2 to whatever variable I have somewhere in my code base, all I do is take num, add num, the function, and then I do 3 or whatever argument I want, and it runs. Now, it ran successfully. It didn't give us an error, but I would really like to see what my new number is. So what we can do is print it and then run that. Oops, print add number 3 actually. There you go. So in the console, you can see that it took my argument, which is 3, it added 2 to it, and then we printed it to the console. If you don't want to have to run the print command every single time, you can also just include print directly in the function. Print. And then let's run the function. So we added print right here, directly in the function. We're going to run it. And then if I were to run this function again, you can see here in the console, I don't have to add print to the beginning because we added it in the function. So now it's printing directly to the console. This is something that you can do when you're playing around with functions. My guess is that when you're actually building out a code base and you're building functions, you don't need to, you won't be printing it out every single time. Because it's just not useful for you after a certain point. So that's our first example. Let's take a look at another example. So sometimes you want to build a function that takes in multiple arguments, and that's extremely straightforward to do. It's almost exactly the same as what we've done here, but instead of one argument, we have 2 arguments. So let's go ahead and do that. num1, num2, and then again we have to provide some context, right? We need to tell R what we want to do. So let's create a temp num, and let's do something different. Let's multiply num1 and num2 together, and we'll print it to the console just for fun. I'm going to save this to a variable called num3. Okay, so let's run num3, and if I were to only use one argument, let's see what happens. It doesn't work. The function is designed to take in 2 arguments, So just using 1 is not helpful. Let's use 2. Oh, num3. There we go. I realized that this was actually referencing the incorrect name, so I want to show you again num3 with 1 argument. There you go. So it tells you right there in the error. We know that the num2 argument is missing, and so it won't work. It tells you right there. You need 2 arguments. So we have 2 arguments. We run it. It's multiplying both numbers, and we get 2. Let's try that with different numbers. 5, 6, 30. Makes sense. What happens if you accidentally input a string? It doesn't work, and it tells you exactly why. We provided a non-numeric, but it wants an integer. So that's always helpful, that type of error. Okay, so we have 2 functions, one that takes in 1 argument, one that takes in 2 arguments. What if you don't want to work with numbers? What if you are building a code base, or you're writing code that takes in strings or files? You can do that in R, and you can build a function that takes in a non-numeric argument. It's exactly the same. As long as you're referencing it in your actual function code chunk, you should be able to work with whatever you want. So let's do that. I'll clear my script here and my console. In this last example, we're going to use a file as an argument, a file name, instead of a number or some other input variable. And I want to show you how you can build functions that take in files instead of just plain numbers or strings or something like that. And I think this is where the real value of a function can be realized, because you don't have to process files over and over again. You just build a function once and then you're good to go. So I actually need a couple libraries. For this example, I'm going to input the Terra library, which is a spatial library, and I think that's it. So that's that. Now let's build our function. I'm going to call mine getRas for get raster, and we need our function. We need an argument, which is going to be a RAS file name. So a raster file name. This is a spatial data example. And let's input our curly brackets. So the argument that I've provided here is the file name of a raster. That's always what it's going to be. And what I want to do is take the raster, take the file name, convert it into a raster. I want to multiply the raster by 2, and then I want to plot it. So if I was doing this for a project and I had 50 rasters, doing that over and over again would be very annoying. So we're going to build a function that does exactly that without having to repeat the same code over and over again. So let's get started. The first thing I need to do is convert a file name into a raster. So I'm going to call it temp_ras, temporary raster, and we're going to use the rast function, which is from the Terra library. And obviously the rast function needs a file name, so we're going to use ras file name. Then, like I said, I want to multiply every single value in my raster times 2. So let's do that. I'm going to call it new ras, and it's going to be temp ras multiplied by 2. And then finally I want to plot new ras. So there's my function. Let's run it. We didn't get any errors, so that's good. Now let's see what happens if we use an actual raster file inside of my function. So we have getRas, and my raster is called s2b2.tiff. Let's see what happens. There it is. There's my my raster. And keep in mind that the only reason we see the plot here is because we've actually plotted it within the function. If I were to comment it out like that and run it again, you wouldn't get any, let me show you again actually. Yes, so if we were to run this again, nothing shows up because it doesn't, we haven't told the function to plot anything. And then if I had the function and I didn't have a plot element like this, and I wanted to plot my function or plot my raster, I could just do get ras with my file name, and then you would see the plot like that. And keep in mind that you can save this function with a specific argument to a variable. So I can call this R1, and then I can just say plot R1. It's the same thing. Run that again. There you go. And then if you have R1 set up and you want to just print R1, you can see all the details of your raster. They're right there. You could even use R1 in another equation. You can say R2 is equal to R1 multiplied by 4. And then you would get another raster. So there's a lot of flexibility in using functions. This is an example where we used a raster file name, but again, if you had a CSV that you wanted to use, or you had a shapefile that you wanted to use, the structure, the applications would be exactly the same. It's the only stuff you really need to remember is just what how the skeleton of a function is organized, and then you should be good to go. Good luck.